There's a belt. There's a belt. Read the question. Now, the belt will have constant velocity. The velocity of belt will remain constant. Who will maintain constant? The motor. Yeah, get into the now. Do first part. We will see the second part. Wheel of mass and radius are. So what do you mean by wheel? What shall I take? Moment of inertia.
He gave radius of gyration, sir.
Where is there? Last sentence. The radius of gyration of the wheel is k. Okay, then we'll write it as mk square. Moment of inertia will be mk square. Where all needed, I'll be using this data. Initially, this is release. This is at rest. What will happen? Very next moment, it will start moving. No? The part A of the problem is what I'm discussing. No, what will happen to the moment the wheel comes in? Can you hear me?
Yes, sir.
Yeah, there's no power with mobile data. We'll carry on the. We'll discuss a few problems. This one. No. I think we were here. Wheel can rotate. Wheel can rotate about C. Okay, there's the initial the discussion of this one. So the friction which is acting. So what it does, the friction which is acting will apply torque, and because of torque, there'll be an angular acceleration. The center of mass cannot. It can accelerate. The center of mass can accelerate, but the friction will not permit. So therefore, it will have angular acceleration. Due to angular acceleration, so what will happen to the wheel? It will acquire velocity. And finally, what will happen? At one point, when the velocity of this point equal to this, no more further friction will cease, will not act. For the next, what is the condition that will arise? In exam directly, you can write the answer. As a teacher, I have to explain. I'm telling all this story. So finally, what will happen? This will be rotating with an angular velocity omega. The velocity of this point should be equal to velocity of this point. Vp1 equal to Vp1 will be r omega. This is u. So what is omega equal to u by r? Now what is the kinetic energy of the disk will be half I omega square kinetic energy. I'll write it here. Omega is what? Kinetic energy, Ke, write it. What is the thing? Now, what is the role of that motor? What that motor should do? How much of work it should do in the part? Everything is visible. Check once. If the motor which is connected to belt, what happen? If the belt is set free, what happen? The because of friction, the velocity of that will decrease. No, you should maintain that velocity constant. So motor, how much of work should do? Will it be only equal to this or twice of this one? Because friction does positive work on this, it does negative work on this one. But the velocity of belt should be maintained constant. So how much of work I should do now here? Half of it or equal to this Ke or twice of this. A work has to be done till slipping occurs here now. Here no slipping occurs. No, let's get into one thing. The kinetic energy of the wheel got increased. From where this energy will come? And the velocity of the belt should be maintained constant. So therefore the motor should do work. How much of work it should do? Twice of this one. So what is the work done by motor? The work done by motor should be equal to increase the kinetic energy of the wheel and also to maintain the velocity of the belt. Okay, to increase kinetic energy we have, but what is the work done to increase work done to maintain velocity of the belt constant? How much friction does work on the wheel? That much the friction has to do work on the belt. So therefore the action agent what happened should do work on the belt also, not only on the wheel. So therefore I'll put it here now. Work done by action agent. Mhm. Okay, we'll have here only. Work done by motor should be equal to increase in kinetic energy of wheel plus work done to maintain I will write on top work done to maintain speed of the belt constant. So this work done, there's a part A we are discussing, no? So this should be equal to how much here? Ke, I'll write it. What about the other part? Should be also Ke. So 2Ke. Let's come for the second part of the problem. What is the second part of the problem says is like, the wheel is gently placed on the belt. The moment I release, so this is will be released from rest. No, you can. It is released from rest. Now, what will happen to this? I think you know we have done many problems of this kind. The velocity of belt will be constant. This is at t equals 0. What are the forces that will be acting? The friction will act here. The friction on the belt should be like this, and this friction will accelerate center of mass, and it will be alpha c, and because of that this will have velocity v1. Will write it all. Slipping occurs. No, slipping occurs. Finally, no slipping. When the no slipping occurs, often the friction will become 0. Velocity of this point will become equal to velocity of this point, and it will have velocity v. This will be final omega. This is at time t equal to t, you write it. We are interested in this thing. So let's get into the kinematics. We'll later on will come into picture. So we'll accelerate the center of mass, the friction. Look at the now. F equal to ma1. Then F into r. There's a wheel, no? Okay, the wheel have IC into alpha 1. As what is the friction? This is a sliding friction, not a rolling friction. So how much F should be equal to mu mg. No, not needed. Okay, if you will write it. So mu g by k square. Similarly, F equal to ma. So this should be equal to mu then for no slipping at time t equal to t. What should be the condition? Vp1 should be equal to Vp2. I have let me write it here. What is Vp1? Vp1 should be equal to V plus R omega. This should be equal to U. What is V equal to? V equal to A1t. What is omega? Omega equal to alpha t. It should be equal to U. So A1 is how much? Mu gt R alpha 1. What is alpha 1? Alpha 1 will be so T is equal to Ku by mu g k plus mu g r square. So there's a time at which the slipping ceases and the friction will vanish. No friction will act here. No slipping occurs means friction will vanish here. At this particular time, friction will vanish. So what is the work done by the friction on the disk?
Mu g k square in the denominator. Alpha 1 is mu g r by k square.
Alpha 1 is mu g r by k square.
Yes, sir.
Yeah. Okay, I just said everything. What is our question now? It's asking the kinetic energy, no? Finally, when the kinetic energy is acquired. So for that, we needed the time. Once you know that time, you can calculate that velocity. So now we'll get the velocity. V is equal to A1t A1 is what? Mu G. T is what?
Or can we directly say F into UT will be the additional energy?
F into?
UT, U is the velocity of the conveyor belt.
Okay, yeah.
No, sir.
Work done by what?
Done by the additional force that the motor provides
On wheel or on the belt?
on the belt.
On the belt.
On the wheel, no force will be acting, no, sir.
No, on the wheel there's a frictional force acting. No, from where the kind
Frictional
of
saying the additional energy, sir, that the motor delivers. To
on the
maintain
belt.
the conveyor belt velocity
Velo.
constant, it should provide a force equal to F
Yeah,
on
that
the
one.
conveyor belt. So we can directly say F into UT.
F
Point
into.
of application of the friction forces changing by distance of UT. So it will be F into UT.
That you can do that one because the well after the belt is constant. No, UT will become displacement. Frictional force is acting. Opposite to that also can do it. Yeah, that's also convenient. Yeah. So this A1 is mu G K square U by so mu G get eliminated. So we'll get this as U K square. Similarly, we'll calculate the omega. Mu G here also will get eliminated. So we'll get only U, I think, here. UR by K square plus K square plus R or R square? K square plus R square. Okay, this we know omega. So then kinetic energy of the wheel when no slipping occurs. We have to further simplify this one. Okay, we'll substitute and I'll move. Okay, this will be V square will be U K square omega will be UR by final equation U square K square 1 R square will come here. Smaller or capital R? Okay, capital R it is. Yeah. Anybody final equation? M U square should be there. K square will be there by 2. Check it. There's a kinetic energy, this one. So again, that what is work done by the motor on the system will be twice of this one. So what is this quantity? We should write it as work done by motor should be equal to 2 times of KE. Okay, this will be your answer, second part. or directly you can force into displacement F into UT, and you know F equal to mu mg. From there also you can bring it, and we know T. Anyway, T has to be determined. Afterwards you can go for that also. What work done by the motor on the belt, the same work it has to do here. The total work done will be sum of these two.